I, Ritik Relhan from Team Cosmic Shala, welcome you all to today's webinar on Search for Life in the Universe. I welcome our esteemed guest, Dr. Mila Mitra, to Cosmic Shala. Dr. Mitra is the co-founder and academic head of an innovative educational company, STEM in Space, that aims to foster interest in STEM education through the exciting domain of space. She completed her bachelor's in science from St. Stephen's College in New Delhi and her PhD in astronomy from Rice University, Houston. She is an astrophysicist who has worked for more than 20 years at NASA on various satellite missions.
When we say search for life, there's so many movies that talk about life in the universe or life that we encounter, right? All the way from E.T., one of the most famous ones, of course, Jadoo, Close Encounters, Wall-E. They make them cute. They make them dangerous. Francis Drake started the concept of search for life. He's one of the main founders of SETI, Search for Extraterrestrial Intelligence. Now, he formulated this equation. How do you determine N, which is the number of technologically advanced civilizations in our Milky Way galaxy? And he started off, this was many years back that he came up with this equation. So he said it is a function of the first parameter, which is rate of formation of stars. Every parameter to the right connects to the one on the left. So the first parameter is rate of formation of stars. The next one, FP, is the fraction of those stars that have planetary systems, because not all stars have planetary systems. Some of them might just be a star on its own. Okay, so the third term, NE, is if the stars have planetary systems, then which of those planets could have an environment suitable for life? Right-hand side, the last two parameters are fraction of civilizations that develop a technology that releases detectable signs, and the length for which such civilizations release these signals. But this is quite uncertain, because what happens if there's microbial life? They won't have any technology, but they are there. So this is an equation that has been really governing the search for life, or trying to model, are there planets that could have life? And if so, are they habitable? Earth now is so hospitable. It's got oceans, it's got mountains and trees. It gets warm at times, but it is cool also. That's what makes it habitable. But in the beginning, it was all very uninhabitable. It was very hot. There were lightning flashes. There were asteroid hits. Most of the atmosphere was nitrogen and carbon based, not oxygen based at that time. So in the beginning, basically, our Earth was a hot soup of such gases. And then the water formed. When there was water, then some of these elements were able to combine and create microbial organisms. So it is suspected that they were formed in the water, first of all. In 1952, there was an experiment done by Mila, who wanted to play with this concept. So what he did was he created a closed system where he took the chemicals that were present in early Earth, which, as I told you, was boiling water because it was lava and hot water. And at that time, it was ammonia and methane were the gases present. And then he subjected them to this whole system to electrical shocks, because that's what, there was lightning. So the electrical shocks were supposed to simulate lightning. And what did he find? He actually found that the color of this system changed into a reddish color. And on analysis, they found two kinds of amino acids. And for any of you who remember your biology, and some of you might be biologists, amino acids are the building blocks of life and create protein. So Miller actually showed that an early Earth, the way the atmosphere and the environment was thought of at that time, could actually have led to life. Mankind evolved from apes, but the way, especially we are going in our lockdown, we are going to go back to crouching and not standing straight because we are back to the internet all the time. So why is our Earth special? Why did life develop there? So that brings us to what are the requirements for life? Earth has these conditions that fulfill the requirements: water, atmosphere, source of energy, and Goldilocks zone. Now, what is the Goldilocks zone? I don't know if you remember the story of Goldilocks that we read when we were small kids. So Goldilocks was a little girl who went into the forest, and she happened to go into a cottage that was lived in by 3 bears: a father bear, a mother bear, and a baby bear. So they had gone out when she went into the house, and she found some soups, some bowls with soups, and one of them was too hot, one of them was too cold, one of them was just right. There is a habitable zone around the sun, and if you're too close to the sun, then it's too hot. So Mercury and Venus, as you might know, are in an area that makes them too hot. So then there's an area which is just right for habitation and for supporting water, and beyond that again it's too cold. So this is called the habitable zone or the Goldilocks zone. There are some creatures that are microorganisms. They're called extremophiles. So there are some creatures, microorganisms, that have been found to survive under very harsh conditions. Like they survive in lava, they survive in Antarctic ice, they survive in in radiation zones. So that means that there are some creatures that can survive in extreme conditions. For example, if you find a creature that can withstand heavy, very high temperatures, then scientists can test with a condition like Venus actually work, which is very hot. Will such creatures be able to survive? I'll just introduce one extremophile to you. It's called a tardigrade. These look very cute to me. They're called water bears. So tardigrades can survive all kinds of extreme conditions. They can go without food or water. They can live in very cold as well as very boiling temperatures. They can be found in the deepest of ocean's trenches. So scientists actually think of taking tardigrades, and tardigrades were in fact taken to the moon. And there was an Israeli mission that crashed, and tardigrades were in that. So by now there might be tardigrades. SETI is the search for extraterrestrial intelligence. So radio telescopes are large arrays. And why radio telescopes? You can't see radio waves with your eyes, but they can penetrate the atmosphere, the dust and gas in our solar system. There are some places that are thought to be potential, very little potential, but yes, there are. So let's start from the beginning. Mercury and Venus, maybe not, but recently, as some of you know, Venus has a thick cloud layer, and in the cloud there have been signs of phosphine, which is a chemical that is sometimes produced by microbes. So Venus is a target, and there will be missions to Venus in the next 10 years, including our own ISRO's Shukrayaan will be going in about 2026. Okay, so the Kepler mission was launched in 2009, and it actually took data for about 10 years. And it's search for extrasolar planets. And it observed more than 500,000 stars, and it found close to 3,000 exoplanets. There are 2 or 3 special ways of finding them. One of them is called the transit method. If you look on the right-hand side, a transit method is the same concept as an eclipse almost, which means that when a planet comes in front of a star, the star's brightness for a brief moment decreases. So that's what these missions do. They keep on observing the brightness of different stars, and over time, they scan it and survey it over time, And later, if a dip is found, that dip might indicate that something passed in front of it. So you can see this graph, the dots in blue, dark blue, are the missions before Kepler, and you can see yellow dots are the ones exoplanet discoveries that were contributed by Kepler. There have been other missions sent by us long back that have now reached interstellar space. This includes the Pioneer missions and the Voyager missions, and these have contributed information on Jupiter, Saturn, Neptune, and now they have reached interstellar space.
I had the question that, ma'am, is there any possibility that life can be other than carbon-based?
See, that's what I said, that the problem is that you're right, it can be, but our scientists have to go with the assumption of life as we find it here, and that is why they feel carbon-based is is one of the telltale signs that they do look for. But yes, it can be otherwise also.
Yes, ma'am. So I had to ask that, have we got any proof till now that there was life in Mars?
The thing is that every year, every mission we send, we are getting additional information. So it's not just a question of have we found it or not. The thing is, what we found is there is no obvious sign of life now. And that itself is a big achievement, because that means we were able to get rovers onto the Mars surface that were able to give us many more answers. So the good point is that there are some promising facts about Mars, but yes, we have not found any conclusive proof of any life anywhere in the solar system yet.